area of a triangle, how do you know how to find the area of the triangle? Formula? Triangle? 1/2 base times height, right? And that works great if you know what the height of the triangle is. Usually you don't. Now, there are ways of finding the height of the triangle, but there are actually a couple of new area formulas that are so easy to use. You're going to love them. This is so easy. So I'm going to show them to you right now. Some new tricks to finding the area of triangles. And I'm going to start, I'm going to go a little bit out of order because I want to do the easiest one first. So we're going to do problem B first. Okay, so this is problem B. We're going to find the area of this triangle. Believe it or not, you're going to type it straight in. There's not even any work. The area of the triangle is 1/2. That doesn't surprise you, right? Because you know 1/2 base times height. It's 1/2 10 times 12 times sine 58. I'm going to type that in on my calculator, and that's the answer to the question. I don't need to do anything else. That's our new area formula. So what did I do? I took 1/2 side times side times sine of included angle. So we call this the 1/2 side times side times sine formula. Now, this is the tricky part though. It can't be any sine. It has to be the sine of the included angle. Do you know what I mean by included angle? The one that's between the two sides. That's the included angle. So I just type that in. That's my answer, folks. Let's round it off to the nearest hundredth, and we're ready to move on. So 1/2 times 10 times 12 times sine 58. The area of that triangle is 50.88. Everybody okay? Super simple. Let's look at C. This is problem C. Your job is to find the area of the triangle. Anybody have an idea? 1/2 16 times 15 times the sine of 84. Perfect. What does she have? She has two sides, and the included angle doesn't matter where they are in the triangle. Any two sides times the sine of the included angle, half of that's going to be your area. Okay, as much as you wish I would just shut up, you have got to agree that is very simple. I got 119.34. Okay, so B and C, done.
Typing it into the calculator, like exactly how you have it too. And it works on like the older one, but for this newer one, it doesn't work. So it's giving me a different answer.
All right, is it degrees or radians? You have to be in degrees.
So we can reuse, yeah.
Huh?
It's in degrees.
Okay, and you typed 1/2 times 10 times 12 times sine 58? Okay, and it didn't say 50.88?
It's like 59 something.
Okay, well, I'll have to look at it. I don't know. Okay. All right, now let's look at E, because E is going to present a bit of a challenge. What's different about problem E? Okay. We are not going to be able to find the area until we find another side. And it doesn't matter which side we find, we just need to find another side. So let's stop and think about that for a minute. How are we going to do that? How are we going to find another side? Jordan? Oh, we could use the law of sines. Oh, let's see. What is that third angle going to be?
69.
I got 67.
Oh, well, I made that one. Oh, yeah, definitely.
Okay? So then I can say, I'll call this side B. So I can say sine 67 over 16 equals sine 49 over B. Would everybody agree with that?
Is that supposed to be 64 or 62?
Oh, I don't know. It's a 62, so Jordan, you were right.
Okay.
I copied it wrong. So that's 69. Okay, now have I got it? Okay. So, is this gonna give me the area? No. What is this gonna give me? So, that's gonna give me side B. And once I have side B, will I be able to find the area? Yeah. So I need to figure out what B is, so I'll do what I've been doing. Cross multiply. And divide by sine 69. So B will equal 16 sine 49 over sine 62. Alright. Do I need to second sign that or anything?
Yes, you do.
No, I don't. I only second sign if I'm looking for an angle. I got 12.93, but I want somebody to double check that since I made a mistake earlier.
Yeah.
Is that right? So this side now is 12.93. Don't forget, you're supposed to be finding the area. So area will be 1/2, always 1/2, 1/2, what? 16 times 12.93 times sine 62. Beautiful, beautiful, beautiful. Now, could somebody else have said, I want to find side A. Instead of side B, I want to find side A. That would work.
But you already given me that is C.
Well, but when you did it, then you do 1/2 16 times A times sine 49. If you use angle A, or excuse me, side A, you would have to use this angle, right? You always use the angle that's between the sides. I found this side, so I used 62. So, final answer, area of the triangle is? I got 91.33. Yep.
With the other ones, you just like you're always gonna have to, instead of just area, you can still use the law of cosine and minus sine.
Let's talk about that for a minute. So, first of all, for this problem, yes. I find the area, I need another side. So I did the law of sines, found the side I needed, now I got my area and I'm done. Now Olivia's looking ahead. She's looking at problem A. You did not do A. And she says, well, what's missing here is an angle. So she said, could I do the law of cosines to find an angle and then use that angle to find the area? You can, but I got something even easier. I told you we were going to have two new ways of finding area. One of the ways is this 1/2 side sine thing. 1/2 side sine to include an angle. There is a special formula for triangles where you have all three sides. So let me back up. To Olivia's point, if you want to do the law of cosines and find an angle, and then do 1/2 side sign, that will work every time. But I'm gonna show you a shorter way. It is called Hero's formula. And it's actually, the guy's name wasn't Hero. It was actually Heron of Alexandria, one of those famous guys from a long time ago. And he discovered, this is so amazing to me, these guys were so smart. He discovered that you could find the area of a triangle, any triangle, if you knew all of its sides, by doing this.
How's that?
Now, let's talk about that for a minute, because we need to know what all that stands for. It's very simple. You're gonna love Hero's formula, everybody does.
Side number minus the 12.
So, first thing we need is to calculate what is called the semi-perimeter. What do you think the semi-perimeter means?
Half of all sides.
Half of all the sides, half the perimeter. So if I know all the sides, I can add them up. It looks like my perimeter is what? What is that? 38? Is my perimeter 38?
Yes.
So my semi-perimeter, which is S, would be 19. So I'm going to take 19. I start with 19. Now, what do you think this A, B, and C stands for? All the sides. So I'm going to take 19 minus 10, 19 minus 12, 19 minus 16. So I found my semi-perimeter, which is half the perimeter, and then I took that number minus each side. Do you think the order I do it matters? No. Just 19 minus each side. Boom, boom, boom. Now let's multiply all those together and take the square root, and that will be your area. So 19 times 9 times 7 times 3, and then square root it, and the area of that triangle is 59.92.
And none of those numbers will ever come out to be like a negative. You subtract it from the.
The only way that would happen is if the triangle didn't exist. Do you remember from back in geometry days, two sides of a triangle have to add up to more than the third side? This would not be possible. If you tried to find the area of this, it would be imaginary, because that's not a possible triangle. These have to be bigger than this.
Okay.
So yeah, in a real life triangle, no, that won't happen. All right, let's try the last one. That is what, D? So we have 11, 15, and 17. We're gonna find the area. How do I know I'm using Hero's formula? See, I just immediately drew that big radical. What about the problem tells me this is gonna be a Hero's formula problem? All sides. Kids, you're not gonna use Hero's formula for anything but all sides, because you need a semi-perimeter. And if you don't have the sides, you don't have the perimeter. If you have all three sides, it's Hero's formula. If you don't have all three sides, then do something else, like 1/2 side, side, side. Okay? All right, so what's my semi-perimeter? Here we go. Add them up, divide by 2, what do we get? Did you get 21.5? Don't panic, no big deal, got a calculator. Now we're gonna take 21.5 minus each side. So I got 10.5, 6.5, and 4.5. That look okay? Did I subtract right? let's multiply them all together and take the square root. Did you get about 81.26? We learned today 2 new strategies to find the area of a triangle. Who can put those strategies in your own words? What are the strategies we learned to find the areas of the area of a triangle? Square root, half the perimeter times half the perimeter minus each side. That's what we do if we know all the sides. What do we do if we don't know all the sides? Exactly. 1/2 side, side, sine. 1/2 side, side, sine. And you remember that sine has to be the included angle. So we had a problem where it wasn't, so we found a side to make it an included angle. Okay? All right. Last section. Here we go, guys. Got some word problems. We're going to draw a picture. Write an equation and solve. Here we go. Hold on to your hats. We're going to find the area of a regular hexagon inscribed in a circle with a radius of 22 feet. Oh my gosh. Is your head exploding?
You didn't say anything about hexagons.
Okay, here we go. All right, so let's back up. A regular hexagon. What does that mean? 6 sides. Inscribed in a circle. So draw a circle on your paper. Draw a circle. Make 6 hash marks as evenly spaced as you can. Nobody is grading your picture, but just so it looks reasonably correct, draw a circle, make 6 hash marks, because it's a hexagon. Join the hash marks with segments, and you will have created a regular hexagon inscribed in a circle.
Mine does not look good.
Okay? Now, we are finding the radius, so that would be a radius, is 22 feet. We are going to find the area of that guy. Now, what did we do just a minute ago? What did you say? Yeah, we're going to turn this into triangles. So instead of drawing one radius, we're going to draw them all. Now, would you agree that every segment I drew is 22? Would you agree that all those triangles are equal? So if I could find the area of one of them, I could times it by 6 and have the whole thing, right? So let's see, I need to find the area of that thing. Is there anything, let's look at this triangle right here. Is there anything about that triangle I know in addition to these are 22s?
2 of the sides are 22.
Okay, what else?
But we don't know anything about the outsides.
What? Well, you're kind of on first track. All of these angles here at the vertex or the center, all of those would add up to 360. Would you agree? All those add up to 360. So how big is each one of them? If they all add up to 360,
60.
Doesn't this angle have to be 60? Kids, you told me that the triangles were all congruent. They are. It's a regular figure. Since there are 6 of them, and I know they add up to 360, then each one of them is 60. Now, take a look at this triangle. Can you find the area of that triangle? 1/2 22 times 22 times sine 60. Remember, all it takes to find area is two sides in the included angle. I've got that. So I'm going to do 1/2 times 22 times 22 times sine 60. I got 209.58. Is that what you got? Now, is that the answer to the question?
No.
No, that's one triangle, and I need times 6. So I'm not even going to round off. I'm just going to hit times 6, and my unrounded answer is 1257.47. That is my unrounded answer. I don't really need to round that one off. Just hit times 6 on your calculator and it will give you the answer. Now, I'm going to stop blabbing here, but I want to make one point. On your test, you're going to have this problem, almost guaranteed. The difference will be, it won't be a hexagon. So what would be different if it were an octagon? With this, exactly. So this angle would be 360 divided by 8. And then once you found your triangle, you would times by 8. What if it were a decagon? Divide by 10 to get your central angle, and then multiply the triangle area by 10. So, hang on. The moral of that story is, if you paid attention and followed this, you now know how to find the area of any regular figure, no matter how many sides it has.
Are you gonna go higher than like 10 sides?
Not unless I say like 14-sided figure. I might say something like that. 14 Oh, wait, did we have a unit on that? Oh, we did. Very good. Remember on our word problems, we must have a unit. Thank you, Olivia. All right, I'll see you guys on Thursday. Have a good day. Next time we see you, we have our last science quiz.
On this board,
What?
can I come after